These are probably not gonna be the same points as update. All right, I'm gonna let this be A, this be B, this be C, and this be D. This is the ordered pair, 0, 0 is the origin. This one is 2, 0. This one is 1, 2, 3, 4. 1, 2, 3, 4, 5, 4, 5. And this one is -3. Move this up a little bit. -2. Okay. So you want to be able to make sure you can plot your points, know which quadrant you're in. Remember, this is 1, 2, 3, and 4. These are on the x-axis. This is the y-axis. You want to be able to find the distance between 2 points. So let's say I want to find the distance between B and C. A lot of times you'll see this little line on top. It means the distance between those. And if you remember the distance formula, I wrote this up here, is the square root of your x2 minus x1 squared plus your y2 minus y1 squared. Okay. And so all that means is you take your x's and subtract them, and you square it, and you take your y's and subtract them. Now, I say x2, it really doesn't matter which one you start with. You just have to start with the same y when you do that. So if I did this one minus this, you need to make sure you do 5 minus 0. If you did 2 minus 4, then you need to make sure you do 0 minus 5. Okay? So just stick with the same pattern. So I'm going to do 4 minus 2, and you square it, plus 5 minus 0. And you square it. And again, I talked about it, you can never have a negative distance. Because if we're describing the distance of something, it's always going to be positive. And that's why in the formula, these are squared, because it makes it positive. So 4 minus 2 is going to be 2, and that's going to be squared. And then 5 minus 0 is going to be 5, and that's going to be squared. Now, you need to make sure when you plug something in the calculator, you put parentheses around something that's being squared, because your calculator doesn't always read that. Just know when you square something, it becomes positive. So this will be 4 plus 25 square root of 29. Just to review back, you can't really break this one down, but let's say I had the square root of 24. Does anybody remember how we would simplify that the most? Does anybody remember how to simplify a radical? You think of it as you want two numbers that are the same to break out, okay? So this is like 6 and a 4, and think about this as a 2 and a 3 and a 2 and a 2. So you have a pair of 2s, so that can be brought out, and then you're left over with the 2 and the 3, which is the 6. So technically, this would be the simplified answer. 29 isn't going to break up into anything, but I just wanted to go over this. Now, if you guys gave me the square root of 24 and you didn't give me this, unless I tell you to make sure to reduce it, I'll probably still take it. You could also just change it to a decimal, and that would work too. So the distance between B and C is going to be the square root of 29. All right, why don't you guys tell me the distance between B and D? B and D. B and D. Find that one. Use the distance formula and find the distance between B and D. All right, so Jackson, it looks like you're correct, and interestingly enough, you're gonna get the same answer as the other one, so, and I did these randomly, so that's interesting. So I'm gonna do 2 minus, this, be careful, is a -3. So again, if it helps you to write them out, you can say this is x2, y2, x1, y1, or vice versa. So I did 2 minus -3 first, and now I'm gonna do 0 minus -2. I'm gonna take the square root of that, so that's gonna be plus, that's gonna be 5 squared plus 2 squared. And you end up with 29, the square root of 29. And if you put that in the calculator, it's gonna be like 5.39. Questions on that? Hopefully this is a review. All right, what about if I asked you to find the midpoint? The midpoint. Anybody remember what that is? Think about it. It's going to be a point as your answer. And when we think about the word mid, the mid means what? Middle. And if we think about middle, what would you say? If I was saying something is in the middle, you would say what? Half. All right. So the formula is you take your x's and you half it, divided by 2, and then you take your y's and divide by 2. And so it's going to be a point. The midpoint is a point that your answer should be in order pair. So let's say we want to find the midpoint of B and D. You would literally add your x's, so that's going to be -3 plus 2. So I'm finding the midpoint of B and D. Okay, so I'm doing -3 plus 2 divided by 2, and then -2 plus 0 and divided by 2. And that's going to give us -1/2 and -2/2, which is -1. So we've got -1/2 and -1 as our answer. And if I check it up here, a -1/2, -1 does not look like half, but obviously my graph is not perfect. All right, why don't you guys find the midpoint of C and D? Find midpoint of C and D. So C is at 4, 5, and D is at -3, -2. Find the midpoint of C and D. All right, so if I find C and D, let's see if I can make a straight line. All right, I'm gonna add my x's, so that's gonna be -3 plus 4, divide that by 2, and then -2 plus 5, divide that by 2. That's gonna be a half, and then 3 halves, which is 0.5 and 1.5. So if you think about it, it's gonna be somewhere around here. Right there. That one's a little bit more accurate, but my drawing's not great. Questions on midpoint? All right, I'm gonna give you guys a question. It's got some different parts in it. And it might be something like you would see on the SAT maybe. I know a lot of people don't even take it. Do y'all still take the SAT? Or is it the ACT? Yeah, when I was going to school, the SAT, everybody took the SAT, and everybody took the ACT, and now it's switched, so. All right, so let's say I'm gonna give you guys, it's just an example, consider the points A, gotta be specific on this, so it works out right. B, 2, B is 31. All right, and I want you guys to be able to first plot the points on a graph. Next, I want you to find the length of each side. Is it a right triangle? And then find the area. So this might be a question you would see on the SAT. They always like to give one question with a bunch of prompts to it. And you kind of have to know what each question is asking for. So the first one is plot the points. Everybody should know how to do that. When they ask for the length of each side, what are they asking for? When they ask you to find the length of each side, what are they asking you to do? Going to form a triangle, obviously, right? Because when you have 3 points, that makes a triangle. How would you find the length of the side of a triangle? Given a graph with the points. We would use the distance formula. So you have to understand that the length of it means the same thing as find the distance of it. Is it a right triangle? So go ahead and at least do these two. I'm gonna let y'all do those on your own. I'm gonna plot them now when y'all are working on it, but go ahead and find those. 2. If the teams thing would work correctly, I would actually plot them on a graph, but it doesn't seem to want to do that. You guys go ahead and find the distance of each of those. We'll talk about it. Can everybody see okay? You have it? All right, let's look at AB. Do that one first. So I'm going to do the 2 minus -2 squared. If you did the other way, it's fine. Just make sure the y's are the same direction. 3 minus 1 squared. So I went from here to here, here to here. That should be 4 squared plus 2 squared. It'll be 16 plus 4. So this is going to be the square root of 20. Okay. Now, if you broke that up, if we simplify this further, this is a 5 and a 4. So this would be a 2 on the outside left over with a 5, because this breaks up into a 2 and a 2. Right, this. A pair of 2s, so 2 square root of 5. If I was to actually write it out, I'm fine with leaving it as a decimal. If you do that, the square root of 20 is going to be 4.47. Oh, this was AB. So we'll say square root of 20, 4.47. Everybody get that? For AB? All right. AC is an easy one, right? Because it's all of the same X. It has the same X. No, excuse me. It has the same Y value. So 1. So we can just count it. So this is 1, 2, 3, 4, 5. So that one's nice because I can literally just count it. And notice you're going from -2 to 3. So you go 2 over and then 3 over, which gives you the 5. And so then the only other one we have to find is BC. And so that one is 3 minus 2 squared plus 1 minus 3 squared. And again, if you did it the other direction, that's fine. So 3 minus 2, 1 minus 3. So that's going to be 1 squared plus -2 squared, which is going to be 4 plus 1. So that's going to be the square root of 5. Which is equal to 2 point something. 2.23. Questions on that? Right, good? All right, now we want to determine, is it a right triangle? Does anybody know how we would determine, is it a right triangle? Where do you think, if it does have a right triangle, what angle do you think it would have a right triangle? I mean, a right angle, excuse me. If it's a right triangle, it means it has one right angle, right? So where do you think it would be at if it did have it? It would have to be at B, right? This would have to be the right angle if it is a right triangle, okay? So does anybody know what formula we could use to check to see if it is a right triangle? Anybody remember a formula that you've learned in the past that deals with right triangles? And it's a formula that everyone always seems to remember. I will tell you that. Yes, Jackson, not quite spelled correctly, but yes, Pythagorean theorem. Okay. Does anybody know what that is? What's the Pythagorean theorem? Yeah, So it's A squared plus B squared equals C squared. And if you remember, here's your right triangle. Your C is usually always your hypotenuse, which is across from your right angle. So on this one, RC would be the 5, the longest side. So what we would have to do is we would have to plug this in to see if it actually works. So I'm going to use my A would be the square root of 20. And my B would be the square root of 5. And we want to see if it's equal to 5 squared. Does that make sense? So we're just plugging it in. Now, when you square a square root, what happens? Now remember, if you square a square root, what happens? It cancels out, okay? So this becomes a 20, this becomes a 5, and 5 squared is 25. So this checks out. 20 plus 5 is equal to 25. So it is a right triangle because I was able to use my Pythagorean theorem and verify that it's a right triangle. So is it a right triangle? Yes, and you would need to show that, okay? And now the last thing is, how do we find the area of a triangle? I remember the area formula. So we're doing a lot of things here. We got to know how to plot points. You gotta know how to use the distance formula. You gotta know how to use Pythagorean theorem. And now I need to know the area of the triangle formula. Anybody remember that one? Good. 1/2 of your base times your height. Okay? And if you think about it here, we turn this, okay? Imagine we're turning this. Our base would be the square root of 5, and our height would be the square root of 20. Okay? So I'm going to do 1/2. The base is square root of 5. The height is the square root of 20. And you could have left these as decimals, but it's honestly just easier to leave them. And if you remember in multiplying square roots, you just multiply the inside. So this will be the square root of 100. And what's the square root of 100? 10. And so then you're doing 1/2 of 10, which is 5. So our answer on this is 5. So again, this will be 1/2 the square root of 100, which we said was 10. It's 1/2 of 10. I'm running out of space down there. But so we did a lot of stuff. That's why I like to get this one, because it goes over a little bit of geometry. And this is like a question you would actually see, because they're not just going to straight up ask you, what is the distance between A and B? They're just not going to do that. So on one of these tests, you're going to see something like this, and it gives multiple parts to each question. If you took the SAT. I don't know. I haven't taken the ACT. I need to go back over and see what kind of questions they would ask on that, but it may be something similar. I don't know. I never took the ACT, so. All right, let's move on. Any questions on this question? Or these questions? Multiple questions. Okay, next thing is you're gonna have to be able to determine whether a point is on the graph or not. So if I give you guys determine whether a point on and let's say we have 2x minus y 6, and I'll give you guys the point 2, 3, and 52. All right, so this is just another part of what's in the section, is being able to determine whether a point is on the graph. And I give you guys, this is an equation, 2x minus y equals 6, and I give you the order pair 2, 3, and 2, -2. And I want you guys to be able to tell me whether these points are on the graph. Now, we haven't learned how to graph this yet. I mean, you probably know, but we haven't gone over that. So what's another way of checking to see if these order pairs are actually on this graph? Okay, Jackson says we could use Desmos. Yeah, you could. You could graph in a Desmos or on your graphing calculator and look at it. But let's say we don't have that. Let's say we don't have anything to check that. What's another way? Well, what is 2, 3? What is this? A coordinate, and we know the coordinate is right, Cheyenne. We're just going to plug it in. We know that the 2 value is what value? The x value, and we know the 3 is the y value, right? So if we plug it in and it's equal to 6, then I know it works, right? It's on the graph. So I'm going to do 2 times 2 minus 3, is that equal to 6? Well, that's 4 minus 3, is that equal to 6? No, so it's not on the graph. All right, I'm going to do this one. 2 times 2 minus -2, is that equal to 6? Well, that's going to be 4 plus 2, is that equal to 6? Yes. So this one works. It is a point on the graph. This one does not work, so it's not. So again, we haven't learned how to graph necessarily, but you should be able to figure out how to graph by just getting points that are on the graph. So let's say I give you guys an equation and I want you to graph it. But again, I haven't showed you guys how to graph a line yet, but I can just come up with values of points to plug it on the graph. So let's say I give you guys, an easy one. So you can actually create a table of points to graph something. And it doesn't necessarily have to be linear. Let's say I give you guys y equals -3x plus 2, and I want you to graph using table of points. Okay? X, Y. So I want you to graph this using a table of points. And we're just gonna plug in values for X. I like to do a few negatives and a 0 and a few positives because that's just a wide range. So I like to do maybe -2, -1, 0, 1, 2. You can come up with a couple of other ones, but it's just a nice variation of points. And then I'm gonna plug these in. So I've got a -3 times a -2 plus 2, unless we can even make our y value here. This part would just be the plugging in part. So you get -3 times -2 is a +6. +6 plus 2 is going to give you an 8. Okay. I'm going to do the next point. -3 times -1 plus 2. It's going to be a +3 plus 2 is going to be a 5. I'm going to do 0 next. -3 times 0 is 0 plus 2 is 2. All right, now I'm going to do 1. Still using the same equation. -3 times 1 plus 2 is going to be a -3 plus 2. It's going to be a -1. And then -3 times 2 plus 2 is a -6. Plus 2 is a -4, right? Let's make 3 plus 2. Yeah. So I've got the ordered pairs -2, 8. -1, 5. 0, 2. 1, -1. And 2, -4. And we can plot these on the graph. And it's going to be a linear graph, so -2, +8, 1, 2, 3, 4, 5, 6, 7, 8. -2, there's that point. -1, 5, 1, 2, 3, 4, 5. 0, 2, 1, -1, 2, -4. Okay, that's pretty good. Okay. Now, if you were good and you had a graphing calculator, you could just type that into y equals and go to second table, and it will give you a list of points. All right, why don't you guys graph this one for me? Y equals x squared. And use a table to graph. Give me some points. Okay, graph that one for me by putting it in a table, coming up with points. All right, so if I were to look at this one, I use a table. I'm gonna do again, -2, -1, 0, 1, 2. Plug it in, -2 squared, no wait, this should be X, sorry. -2 squared would be 4. -1 squared would be 1. 0 squared would be 0. 1 squared would be 1. 2 squared would be 4. And so we would plot those points. I actually have the graph up here. Let me share screen. And I pulled it up. I don't know a lot about Desmos myself. All right, so here's the graph, but if I actually plug these in to the table, we would do -2, -1, 0, 1, 2. And I would do, this will be 4, 1, 0, 1, 4. So you can see there's the graph. You could just type in y equals x squared and see the graph and pick points from it too. But this is Desmos. You can see this, right? Okay. This is Desmos. It's a online graphing tool if you don't have a calculator, but it's just another way of plotting points. Now, let's say you have an equation and it's not like easily giving you y equals something. Then you do need to know how to solve something for y in order to put it in that, and that just makes it a little bit easier. So for example, let's say I give you guys the equation, something like, if I give you, let's say it's 2y plus 3x minus 5 equals 4, right? You don't want to have to plug in your x and your y and do all of that every single time on a table, right? So it's easier to just go ahead and solve this for y. So when you do a table or plug it in the graphing calculator, it's much easier. Because in a graphing calculator, it's going to have to be y equals, okay? So you need to know how to solve for y in a case like this. So does anybody remember how to do that? First of all, I want to get this 2y by itself first, because that's where your y is. So I need to move all of this over to the other side. The easiest thing to go ahead and do would be to move your coefficient or your constant value. So this is going to be 4 plus 5 is equal to 9. All right, then I want to still get this by itself. So how do I move this 3x over here?
Just change the sign.
You just change the sign. So we do the inverse of plus, which is minus, and we subtract it. So it gets rid of over here, moves it over there. So we have 9 minus 3x over here equals 2y. And then the last thing is we want to get rid of the 2. So these are multiplying. So what's the inverse of multiply? Divide. So we would divide by 2, divide by 2. So this becomes y equals 9 halves minus 3 halves x. And you can plug that in the graphing calculator and get your points. Or you could make a whole table of values. But I just wanted to go back over solving for y, so that way, if you have one that you need to do that for, you can. All right, the last thing is being able to pick out like intercepts on a graph, so like an x-intercept or a y-intercept, and just being able to know the definition of those. That's the last thing in this section. And then Thursday, we'll go over 1.2. Screen still. That's fine. Sorry, guys. So y'all didn't see any of that hardly, did you? Do I need to write that back up there, guys? The solve for y, are we all able to see it? Do I need to write this back up here? It was this 2y plus 3x minus 5 equals 4. You could still see it? Okay. Well, let me just write it again. So what we did is we added the 5. And this was 9 equals 2y plus 3x. And then I moved the 3x over. These are not like terms, so we just write this as 9 minus 3x. And then the last thing I did was divide by 2. And so you end up with y equals 9 halves minus 3 halves x. And this is what you would be able to put Desmos or plug it in on the table. Okay. All right, so the last thing, I got about 6 minutes. Is picking out the x-intercept and the y-intercept of a graph. So let's say I gave you guys a graph and it looks like, okay, it's a polynomial of some kind. We don't know what the graph is, but can you tell me what is the x-intercept of this graph? And then what is the y-intercept? And then we're gonna have to be able to know the definition of these. The x-intercept is what? Can anybody tell me?
Talking about times bigger.
Oh, intercepts across it. There are 3 intercepts, yes. What is the x-intercept specifically? There are 3 intercepts. Okay, so 2 and -2 are gonna be your x. So we're gonna say 2 and -2. So here and here, your x are where it crosses the x-axis, and then the y is gonna be at +1. So you guys also have to tell me specifically, this is the ordered pair 2, 0 and -2, 0. So what can you tell me about the x-intercept specifically? Besides it crosses the x-axis, it's where the graph crosses the x-axis. What else can you tell me? What do you notice these 2 ordered pairs have in common?
So I can see, but it's just one's
Right, but the same what? What value do they have the same on?
x.
No, because this is -2 and that's +2. Y, okay, and the y value is specifically what? The y coordinate is 0, good chance. So when you guys tell me the definition, this is what I want y'all to remember, okay? The x-intercept, the y value is 0. So when you write the definition of an x-intercept, you're gonna say where the graph crosses the x-axis and y is equal to 0. That is what I want you guys to remember, okay? What about the y-intercept? This is the ordered pair 0, 1. So what do you think is going to be the case for the y-intercept? The x is going to be 0, okay? So the y-intercept, where the graph crosses the y-axis and x equals 0. Again, key thing, x equals 0. So if you ever have to find the x-intercept or the y-intercept, you know what to plug in, right? If I give you guys 2x plus y equals 4, and I want to know what is the x-intercept. Well, we know y is going to be 0, right? So I know that for the x-intercept, the y is 0. So all I have to do is plug that information in and I can find it. 2x is equal to 4 divided by 2. So I already know a point just by doing that. I know the order pair is that has that point is 2, 0. If I want to find the y-intercept of this, I plug in x equals 0 for the y-intercept. Okay, plug that in, you get y equals 4 just from doing that. So that's why I think it's important for you guys to know exactly what the x-intercept and y. If you automatically think, oh, x-intercept, y is 0, you can get a point on a graph so quick. Same thing for y-intercept, x equals 0, get a point very quick. And if you could forget that, just graph it and look at it and it'll tell you, okay? All right, I'm not gonna give you guys any homework for those of you that have not done your quiz, or if you've only done your quiz one time, what do you need to do? You need to go back and do it again to get a better grade, unless you made 100 the first time. But, so we finished 1.1 tonight. If you have not done so, get the highest grade you can on your review 5 quiz. And when we come back in on Thursday, we're gonna finish, section 1.2, which is on solving equations and rational equations. If you guys have a question about something, shoot me an email or call me. And I will see you guys Thursday.